So 10.5, we're going to look at probability of independent and dependent events. At the top is the probability general formula, right? Your successful outcomes over all possible outcomes. We have this one already. But I do want to define independent and dependent events for you. So independent events are events where one outcome does not affect the other event. Okay? So, for example, remember my bag of marbles from yesterday? No. If I have you draw 2 marbles this time, but you pull one out and then replace it, my second draw has nothing to do with my first one, correct?
Correct.
Because you have the same amount of marbles as you started with.
Sure.
Those are independent of each other. Dependent events are events where the outcome of the first one does affect the outcome of the other. So if you pull a marble and then you keep it, now there's less marbles to choose from in the bag, correct? Okay? It's kind of like the CDs. Remember how we had the box of CDs and we were pulling those? Those are dependent events because what you pull the first time affects what you pull the second time. Okay? Alright, so here are the formulas for those. Probability of independent events is basically the same as what we've been doing before. If the word is and, you're going to multiply the two together. So it's exactly what we've been doing before. We have only been working with independent events so far. Okay? Dependent events is a little bit different. So you take the probability of the first event A times the second event B after A has occurred. So usually B is altered a little bit. Okay, so like with our CDs, remember how we pulled a jazz CD? And then when we pulled another one, we had to decrease the number of total CDs because we kept the first jazz CD out. That's a dependent event. That's what we're doing right here. Okay, so then there's also just a reminder for you, if the word is and, you're going to multiply. If the word is or, you're going to add, just so that you always remember that always takes into consideration. Okay, so for example 1, all we're going to do here is define if they are independent or dependent events. That's all we're doing. So the color of a car selected at random and the type of transmission selected at random. Are those independent or dependent of each other? Independent. The color of the car has nothing to do with the brand of transmission that you're using. So they are independent of each other.
So everyone has and.
Not necessarily. You just have to. We have to take each event individually. Okay, so a letter of the alphabet selected at random, and then another selected at random. Are those independent or dependent? Dependent. It actually, this question is not worded very well. If we pick a letter and then you have to pick a different letter, then they would be dependent, right? So let's say no replacement means they are dependent. Okay. If I had a bowl full of the alphabet letters and you pull one out and then you stick it back, then they would be independent. But if you keep it, no replacement, it's dependent. Okay, here's one that I've been trying to nail into your head since the first day of school. Completing your homework and earning your grade on a test, independent or dependent?
Dependent.
Dependent.
I have a good grade. I didn't do my homework.
What's your grade?
Okay. All right, what about if you have a die and you roll a 1 and then you pick up the same die and roll a 3? Are those independent or dependent? Independent, because the first roll has nothing to do with your second. Okay? So those are independent and dependent events. You do have to be able to recognize between them. Dependent are the ones where you're going to be changing what we've been doing. Like I said, so far we've been working with independent. So let's take a look at example 2 then. A card is to be selected from a deck of 52 cards. What is the probability that it is a black card or a 10? This is a review question of what we've been doing before. So we are looking at the probability of it being a black card. How many black cards are there? 26 out of 52. Or a 10. So am I adding or multiplying? Adding. 4 is adding.
Adding.
Correct.
Or a 10. How many 10s are there? 4 10s. And then Guadalupe said what?
2 are black.
Yeah, we have 26 black cards and 4 10s, but 2 of those 10s are black, so we have counted them twice. So we need to subtract 2 out of 52 because we only want to count them once. So that's going to give me 26 plus 4 is 30, minus 2 is 28 over 52. Both of those reduce by 4 to give me 7 over 13. That's just a review question.